Okay, thanks. Is this working? Okay, cool. Hi. So it's a real pleasure to be back here. The last time I was here was February 2019, and I left Paris and ended up back in San Francisco with COVID. And then it's exciting to be back 18 months later or so in person, and the whole place is opening up again, thankfully. I'm here to talk about kind of a concept that we've been working through in terms of a narrative, the idea that we're not saying decentralization equals encryption, but the fight for encryption, and especially end-to-end encryption, we believe is now going to get replaced by a fight for decentralization. And blockchain, cryptocurrency, all the systems we've been working on, continue to work on, are, I believe, getting co-opted in many cases by organizations, governments, companies, and turned from the systems that we believe are beneficial in their decentralization aspects into something which is quite different. So let's start with, what do you mean by encryption? And in this aspect, many of you are probably very familiar with what encryption is, but I want to kind of develop a couple of nuances here. In the simplest form, if you've never heard of this, it's a way of taking data and making it so that someone in the middle of a transaction, let's imagine I'm sending a message from myself to someone in the audience, someone gets in the middle of that transaction and they try to read that message. The idea is they would not be able to do that. And this idea dates back a very long time, really into very early history. There's examples of it used in Roman times and before. There's a cipher called the Caesar cipher, I believe, from Julius Caesar. And the basic idea is how do you keep information private when you're moving it? It's been really the key to privacy on the internet. And you may not know that the very earliest web protocols, HTTP, not HTTPS, didn't include encryption at all, and it still does not. There's still HTTP available for many aspects of protocol communication. With the introduction of the SSL or TLS, it enabled e-commerce to happen. It enabled you to be able to securely enter information on a web page, your credit card information, other private information, and be sure that when you communicated that to a web server, that transit was secure. Now, once it's on the web server, they may store it badly and get hacked, and all sorts of other things might happen. But at least that communication component was secure. And without this, we wouldn't have online banking, we wouldn't have Amazon, we wouldn't have anything that we would take for granted in Web 1, Web 2 world. We now see not just encrypted services, but in some cases, end-to-end encrypted services. Now, just taking a series of things, we've got some payment systems on one side, Venmo and PayPal, but if we just kind of take the aspects on the left. So probably many of you communicate with Telegram, but you might not realize that it has encryption that functions in a different way to what you'd expect. Whereas WhatsApp does actually have end-to-end encryption, so does Signal. So when you're looking at some of these systems and you're saying, which one am I using, why should I use it, and just be really conscious and be careful that you take a look at how these systems encrypt information, how they store the information. Is it stored unencrypted on the server, for example? So a difference between setting up a Telegram group or a WhatsApp group, if you notice when you add somebody new to your WhatsApp app group, they can't see the information that was there before. In a Telegram group, however, that data of what was said before is stored on a server. So when you set up that group, somebody gets added, you just bring that information in. So lots of us like to use Telegram and crypto, but it's my least favorite choice. Well, maybe, I guess, Facebook Messenger and so on would be even lower, but it's not my favorite choice of a really secure mechanism of communication. There are ways to make and use it in a more secure way, but there's nuances there. Some companies now are really just trying to push the idea. There's huge billboards now in Berlin saying Apple is privacy. Trying to push the idea that instead of selling your data and building businesses around it, they're going to instead make privacy a feature. So end-to-end encryption is just essentially under attack. And just like as you see in the crypto markets today, whatever reason an organization, the government, the narrative can find for why Bitcoin is bad or Ethereum is bad or stablecoins is bad is like whatever is the latest reason. The latest reason is ransomware. So it's like, therefore, let's ban crypto. The same thing with end-to-end encryption. We have a constant series of negative narratives around such a bad person did a bad thing because they used an encrypted messaging system. Therefore, we need backdoors to everything. And this idea that, you know, if you can just surveil all the people all of the time, you'll solve all the crimes forever, is deeply flawed. And it really ignores the truth, which is that most crimes are solved by just essentially people working undercover. You know, it's more like James Bond than it is the Bourne Identity? Yeah, that's the one where everything's scanned and you just press a button and bombs get dropped. It's much more James Bond. It's much more like undercover, people pretending to be a part of a cell and then actually catching the bad guys. So there's certainly cases where you could argue that these things would be good, but I think on the whole, this is a negative thing to just put backdoors and everything. And the other problem with backdoors is that if the government has the back door, how can you be sure that the government is secure? You've got a central organization, they also get hacked, gets leaked, so you actually make yourself less secure. We've had a lot of negative stuff around platforms like WhatsApp, and we've had a lot of like awareness now. This has led recently to a large shift to Signal, Telegram, other platforms. And some sort of like recent news around this stuff, you just really seen, and this is headline today also, but just really seen like this very large push against encryption, end-to-end encryption especially, on a global basis. There are legal fights to try and defend it. There are groups like the EFF. It's like a long war here that we're trying to get there. But really, the idea of privacy, we believe, and I hope many of you share this, is really fundamental to how we build the future. And it hasn't helped this last 18 months. As I said, last time I was here on this very stage was right before the pandemic started. And it was so early that when I went back to San Francisco, they wouldn't test me because they said that I hadn't been in China, so therefore I couldn't have caught COVID. So this global crisis that we just went through, yes, it's not comparable to something like 9/11, but the kind of controls that have been put in place, like in 9/11 we had the Patriot Act right afterwards. And the Patriot Act is still in place. That hasn't suddenly been rolled back. There isn't some initiative where people say, hey, you know what? I don't know if we need that law anymore. Let's just get rid of it. Let's get rid of all this surveillance stuff. We don't need it now. Instead, it actually gets doubled down, and Patriot Act 2 was even tougher than Patriot Act 1. And so now we have controls in place where probably most of us have got some kind of passport now. EU passport thing says, oh, you've been tested, or you're good. If you haven't got that, or even if you do have that, you're basically KYCing, if you know what that means. It's like know your customer. You have to identify yourself every time you go into a store in some countries now. You go in, you scan a code, you write information on a website. Oh, I was at this store. Oh, I had to do this thing. When you enter countries now, the amount of information, the amount of tracking that we are voluntarily give people. It's like we're trying to fight using GDPR, we're trying to fight using all this privacy, but we're just opting in to giving our information away. So it's a constant fight, especially when you have things like COVID kicking around. So what's decentralization got to do with this? We all think about decentralization. We tend to think about it as, I don't know, it's like it's a cool thing, get rid of the big guys. Like let's make it like decentralized. Well, why? Why make things decentralized? Well, to me, decentralization is actually about doing things in a permissionless way. So let's go back to I was actually working on distributed systems a couple of decades ago, and before we had crypto, but back then it was for different reasons. It was for resilience. So you build distributed systems so that your data centers don't fall apart when one hard drive falls over. In this case, what we're looking at is saying, in the case of Bitcoin, the decentralization was to break a specific system of centralized control. That centralized control structure allows you to censor things, it allows you to control things, allows you to really harness what you can do. You can decide, no, that transaction is not going to go. That bank account gets frozen. Or this is how we, kind of on a more macro level, this is how we control economies through money printing, etc. So we can kind of get into the macro side of that after the talk. But Bitcoin was an answer to this very centralized control structure of storing wealth. Now, Ethereum comes along. I think I have some examples here. So Ethereum comes along and says, that's great, but now we want to run code. OK, what can you do with code? Well, first idea was, well, let's create new currencies. This was actually on the very first example on the Ethereum page. Let's create a new currency. So this led to this thing, the ICO space. So the ICO was really a way to route around the centralized control structures of fundraising, VCs, angel investors. It's like a little closed club of people where you have to go in and have the right idea, look the right way, have the right deck, and then maybe they'll bless you and give you the right money. Ethereum comes along and says, hey, you know what? How about we just make that permissionless? And yeah, more bad ideas were created than good ideas, but there were some really good ideas that came along, and many years later, we now see some of these companies creating the space that we're in now. So this idea of breaking a centralized system and control, how does that apply to privacy? Well, this is what we started working on a few years ago. So Orchid is a decentralized network, and the network contains node providers that run VPN services. That's our first example. The basic idea is this. So normally when you have a VPN, you think, well, I'm private, right? Well, if you start searching for VPN companies, there's a few out there that are big and so on, but there are hundreds out there. And when you get to different countries, there's even more. You're like, well, which one do I pick? Well, I think just yesterday, there was one VPN company got hacked. All the customer data was lost. So in that case, you've lost credit card information, user data, and so on. Well, you're like, OK, well, that happens all the time. So what's the big deal? Well, in a VPN, what you're doing is you are sending your data through that VPN in order to get yourself an encrypted and private connection to the website or other resource that you're trying to get hold of. Now, people use VPNs for lots of reasons. One of the most common reasons is what we call geoporting, which just means like, I want to watch HBO Max, but I'm in Germany. OK, I get a VPN that makes me look like I'm in the United States. I happen to have a subscription, so I can still do it, right? And hopefully HBO doesn't detect that I'm using a VPN, even though they often do. Other examples, if you're connected to the public Wi-Fi here, the open Wi-Fi, I'm sure these guys are very trustworthy, but you might want to use a VPN because all your data is going through them. So that's another example where you might want to use it. Airbnbs, other kinds of things. But in a more general sense, people are using these things to make sure that you can't figure out who they are and where they're going. Now, the problem with VPN is that the VPN actually knows that information. There's one person in the middle who knows that information. And occasionally, they're not such a good actor. And occasionally, they get a knock on the door from somebody big and say, hey, you might need to hand that over. And usually, they do. So our idea was, what if we could add more than just one VPN? We could add more than another one. And this concept of being able to string different providers together in a secure network is called onion routing. You may have heard of Tor, which is an open source project that predates us. We adapted that idea, incentivized the provider network, and enabled it to give you this concept of no one in the network knows who you are and where you're going. So given all that, the question is, what does Orchid do? Well, we just provide the software for the node providers and for the people to use. How does it work? Well, we're not in the middle making any decisions, but the software has some interesting properties. This simple system I described has some problems when you try and add it into not just Ethereum, not even just really fast layer 2s or other things that are going to get faster and faster in the future. But it has some problems when you start getting into a very simple problem of what we kind of call decentralized services. So if I'm the client and I want to get some service from one of you in the audience, I'm like, OK, I want to pick this guy over here. So he's going to provide me VPN service, and I'm going to pay for it. So who goes first? So do I pay him first, and then he gives me the service? Or does he give me the service first, and then I pay him? And if you've got a fully anonymous system, you just don't know whether or not the person's going to pay or whether or not the person's going to provide the service. Now, if you can, and there's no real solution to that, but if you can get that interval smaller and smaller and smaller, then your financial exposure to the loss of service or the loss of payment gets really small to a kind of minuscule level. In order to do that, you need to put the payments into the data. You need to put the payments into the packets so that every packet you send has a piece of has a payment associated with it. How do you do that on blockchains where we're struggling to get to payment network speeds, never mind data network speeds, which are significantly faster. So what we do is, I think it's actually this slide. Maybe I can go back as well. Does this play? No, it doesn't play. There's a cool version of this where it kind of plays and it all expands. But what we do is we take the payments and we, instead of sending actual payments such that that payment is something you could go and sell or do something else with it, we send you a chance of a payment. You send you a ticket. Like we call them probabilistic payments, probabilistic nanopayments. So you're sitting there receiving, as a provider, you're sitting there receiving these nanopayments, not just from one person, but from many people. And this is quite different to other payment channels in that it's many to many, and also like permissionless in the way it works. Such that then, over time, and it doesn't have to be a very long period of time because we're talking data speeds, you get the expected value to be the same as if you'd actually got all the payments. So this is what we call probabilistic nanopayments. We've been looking at adapting this to other kinds of ideas. It turns out that certain other kinds of services like streaming and potentially storage work really well with this. Come back a bit. There's a staking component to the system. The staking is essentially a form of advertising. So the node provider says, I've got this much ORCID, OXT is the staking component. I'm going to put it up. And essentially, there's a financial risk there, because I could have done something else with it. I could have put it in a cool DeFi project instead. But I'm going to put it up against the node in order to receive traffic. The more traffic, the more OXT there is there, the more traffic that goes to that node on a random weighted selection process. I think that's all the aspects of that. Yeah, so the hops. You can put a single hop in there, and it's just like a VPN. And then you're kind of like, well, so what have I done differently? Well, you've done a couple of things differently. You add more than one hop. You've got the, no one knows who you are and where you're going aspect. There's a couple of different aspects in this, in that you don't need to put a credit card information in there. You don't need to put your name or anything. You can just go get some crypto, put it into the app, and off you go. Now, putting crypto into the app is tricky for most people. And whilst all of you, I'd love for you to use ORCID, we're actually trying to go larger than this and get people who've never even heard of this crypto thing. Or maybe they've heard of it, but they definitely don't know what MetaMask is. So we did another innovation here, which is that in addition to all the stuff I've talked about, we said, well, could we figure out a way to have this connected to the regular world, the world of in-app payments, where you just take your phone, double-click when it says, do you want to add some credit to your ORCID account, and it just works. So you haven't had to go and use RAMP or something like that and add MetaMask and all these things. You've just actually just done one click, and it works. So the way that we did this is instead of using that payment to go buy the OXT and then bringing the OXT back and turning it into nanopayments, we created this kind of structure where you have a series of credits out there that are automatically created, and it creates smart contracts full of nanopayments just from doing a fiat transaction. The other big innovation we made in the last year or so while we were all locked down, we got busy, is we didn't want to switch off Ethereum. We really like Ethereum. We were very happy with our choice. But we wanted to add an extra scaling solution. So we made it so that we can use any EVM-compatible chain. And the first one we used is XDAI. We're adding some others right now. And so now this is very important to us because even though the nanopayments are cheap and fast and very efficient on gas, constructing the nanopayments contract for each user was pretty expensive to the point where it got to, I don't know, like $20 or $30 for the minimum buy-in. We've got that down to less than $1 or so now. It's not a subscription model for VPN, so you could download it now. Actually, if you scan this code, it will take you to the download page. Although, check the URL, it could be weird. You get to that URL, you can get started, and it's pay as you go, which has some disadvantages if you're a heavy user. But if you just want an app with VPN service you want to download right now, you don't want to give a bunch of information out, you can do that. I'll leave that up for a second. I think I'm running towards the end of it. I'm not sure. I guess I'm about 20 minutes in. I'm going to stop now for some questions, but kind of where are we going with this? The company, the organization, the project is really focused on privacy, really focused on specifically decentralized aspects of systems to improve privacy. We're continuing to promote the app, continuing to get some good growth there. But also now we're starting to look at these other applications. So if any of you out there are interested in looking at nanopayments or other ideas that I've been talking about, come find me afterwards. If everyone got the QR code? One more in the audience there. It's going once. Okay. It's available iOS, macOS, and Android. Windows might be coming soon. That's just a really strange picture, but it's cool. This is how you find me. I'll be here for the next couple of days and be very excited to chat. Any questions, let me know. So just a mic drop. All right, find me afterwards if you have questions. Thanks.